Hey, it's Mr. N here, and we are going to do some derivative sketching. So we're going to practice sketching the derivative of each of the following graphs that we see. So for this first one, the best thing to do first is to find your horizontal tangents. So we're going to find all our horizontal tangents. And remember, these are the slopes. So when I graph the derivative, this slope is going to be my y value. So for the derivative here, I'll have the same x value, but then I'll have a horizontal slope because this is a horizontal tangent, so that slope will be 0. Same here, I'll have a horizontal tangent, so that slope will be 0, and that'll be 0. So you're kind of making like a chart of x comma f prime of x at that point, so which is the slope. So now we got to take a look at what's happening on these next parts. Over here, if you take a look, if we start on this side, you can see that these are all negative slopes, and the negative slopes slowly go to 0. So since they slowly go to 0, slope is negative below the axes. So when I graph these slopes, they'll be below the axes, and they will slowly come up to here to 0. So in other words, these slopes are coming all the way up through 0. Now somewhere over here, I'll reach a maximum right here, maximum positive slope. So the slopes go 0, which they do, then they turn positive, so I'll be above the axis, and somewhere here, it'll be a maximum. You could try to draw a tangent line here and approximate it. So I'm going to just kind of guesstimate that that's going to go up to about 2. At this value right here, that's going to have a slope of 2. So this graph will come up like this. Through this 0 point, nice and smooth, up to here, and it flattens out. And it looks like the slopes now turn. If you take a look, they turn and they go back to 0. So in my graph, it's going to turn and go back to 0, nice and smooth. And over here, it's going to hit a maximum negative slope, and I'll just put that at 2 as well. So this curve will look something like that if I continue the trend. And I could verify this because the red curve looks like it's maybe a 4th order, and then the blue derivative looks like it's a 3rd order. So that's just a rough sketch of this. Now for number 2, same type of thing happening. I want to find the horizontal tangents right there. So that's going to be a 0. This is actually a kink. When I created the problem, I wanted to make it as a kink. So I'm going to tell you right now that this is a kink. So you have a smooth curve and a smooth curve that meet up at a kink. So since it's a kink, that means it's going to be undefined there. So now we got to take a look, and we see that these slopes are negative, so it's below the axis, and it reaches right here. We're going to say probably maybe about a -3 or 4. You could actually draw a tangent line right there and calculate that. So we're going to say it's about a -3 or 4. So I'll put an open circle there because it's a kink. And now on this side, they become positive. So these slopes turn over here and become positive on this side of the graph. So up here, it hits 0, so it's going to come up, hit 0, and then turn positive. So this will look something like, possibly something like this. This looks like probably a 2nd order, so when I graph this, it might be something like a 1st order, like that. Okay, on the other side, again, I can try to calculate this right here, and perhaps that's about a 4 or 5. I'm just, again, guesstimating. So I'm just going to put an open circle there, again, because it's a kink. And these slopes are all positive. Notice the positive increases in value as I move along the x this way. So the positive increases in value. So we're going to go ahead and sketch that to be like that. Okay. Moving on to the next one. So for this one, again, I'm going to start with horizontal tangents, but I don't have any horizontal tangents. Instead, I have all these kinks that are going on. So these are points that are undefined right here. And these are constant slopes. If you take a look, that's 1 over 1. So that's going to have a slope of 1. So I can go ahead and plot this. And I'll put an open circle. Let's draw it as an open circle at 1, and it goes in that direction. On this side right here, so I'm taking a look at this. This has a slope of about 5 over 2, and it's negative. So I'm going to go down over here to 5 over 2, so that's negative 2.5, open circle, and out to here, another open circle. And then this has a slope of 0, so it continues on from here in that direction. Okay, now for the last one. Taking a look at this, let's start with this branch of it. On this side, the slopes are all negative, and they increase in negative value, then they suddenly increase exponentially. After this point, they increase exponentially in negative value. So to graph something like that, I'm going to start here, and I'll move along, and then I'm going to increase in negative value, like that. Moving on to the next side. Over here, on this end, let me highlight this for you. These are all negatives as well, but they start off as really high negative values, negative slopes. The slopes are really steep here, and then they slow down, and the slopes almost go to 0. So it's kind of the same thing that's happening here, but in the other direction. So they're going to start off negative, really high, and then slow down as they come up. So let's go ahead and plot that. And again, I am below the axes right here because these are all negative slopes. If these were positive slopes, I would be above the axes graphing it up here. So let's go ahead and put this in. And this is going to be something similar like this on this side. So that's a little summary of how to sketch the derivative. So hopefully these practice problems have helped, and good luck sketching your derivatives.